Here we have a very typical exam question. We're given a function and we're asked to find the asymptotes, intercept, and then graph this function. Let's do our analysis and go through one of those steps, each one by one, and then we will at the end arrive the graph of this function over here. Let's start with the asymptotes. We have a horizontal one. It's the easiest one to find. All horizontal asymptote says is we're looking at end behavior when x is really big to the negative side and positive side. If you were to pick, say, x equal to 1,000 or minus 1,000, evaluate it in there, and that give you enough clue what happens when x is really big and really negative. As you can see, when x is positive to the on the opposite side over here, it's a little less than 1. Here's my x-axis, and here's 1. So it's a little bit smaller than 1. And if it's from the negative side, it's a little bit above 1. So we'll have those two arrows, A and B, over here. Let's take a look at what happens to the vertical asymptotes. Vertical asymptotes happens where the function is not defined. Since we have a denominator of x minus 1, when x equal to 1, the function is not defined. So we're going to draw a vertical one as if it's a hole. You're going to fall into the hole, a cliff, sort of speaking. And then I'm going to just pick a number that's close to 1 on either side, 0.999 and 1.001. That's from this side and from this side. And once again, we're going to do the same little thing. We're going to plug this number in there, and you can see on one side, function is going to approach positive infinity, aka blows up on this side. And if it's a 1.001, which is cross 1 over onto the right side, and then it gets to be a negative infinity. So all I'm saying over here is I draw this arrows on C and D to indicate the end behavior. Once again, the asymptotes is always asking about the behavior of the function. It's not terribly accurate to say it's a point per se, but the behavior. As x close to 0.999, as close to 1 as you can get, the higher and the more value, bigger value happens to be the fx. That's why I drew an arrow over here indicating as close as I get, this function is going to go upward. All right, so that's the asymptotes. Now let's take a look at the intercepts before we connect it all up and graph this function. All right, we have a lot of good stuff doing over here. We're on to the step B, finding the intercept. Now, of course, the intercepts are two interesting points. We're interested to see where the graph cross the x-axis and y-axis. The easiest to find, of course, is the cross when x equal to 0. And that's when crosses the y-axis. If I just plug 0 in there, I can see f of the 0 function becomes 3. That gives me 1 point on the function. So 0 and 3. That's this point over here, point P. In order to find where across x-axis, that's when y is equal to 0, I have to set the function equal to 0 and proceed to solve it. When x equal to 3, 3 minus 1 is minus 2, minus 2 and minus 2 become a positive, my apologies, 3 minus 1 is positive 2. Minus 2 over positive 2 is minus 1, plus 1 is equal to 0. So the function crossed the x-axis at 3 and 0. That's the point M over here. Now if you connect, that's the part C now, connect arrow AB, that's here, that's the x asymptotes, and C and D, that's the vertical asymptotes, and the fact it's cross x-axis and y-axis at those points P and M, and connect everything together. We have 6 points basically for our end behavior, and cross this point, the purple one is what the function look like. Now on the next slides, we'll take a look at computer generated duplicates exactly what the function looks like. This one is a little bit out of focus. Here's a computer-generated graph. As you can see, here's the horizontal asymptotes, and then here's the vertical asymptotes that happens where the function is broken up undefined, or function is undefined x equal to 1. Well, I hope this helps. Hi, this is Dr. Pan recording from Tucson, Arizona. Please comment or share this video, or hit a like button. Together we can make math easy again. Have a confident day.